When I was a kid, I really liked to collect wrappers from bubble gums. And it was kind of cool, you know, to find the nicest, the coolest cars and trying to get at the biggest collections from like Turbo or something. And it was also interesting to exchange those stickers, wrappers with other folks. And how did we define what was the best car? We just looked at the picture and trying to say, oh yeah, this car is red. It's cool, nice. And it worked really well when we were young, but things are totally different when it comes to the real world of high-speed bolids. Right? If you go through the rules of Formula One, you will see a lot of restrictions, like the minimum weight of the bolide, the maximum speed, right? The content and temperature of the fuel inside. And those major players in Formula One, they spend hundreds of millions of dollars just to predict and to create the best car following those restrictions. And it is very important for them to have, obviously, the best engine, right? They pay a lot of attention to the aerodynamics, just to have proper turbulence, for instance, for the car. And every single driver has really to know its own car, because each car will behave differently on different tracks. And for any company and for every driver to be successful, he needs to know all the details. And this is kind of similar to what happens with telemetry. With telemetry, you can go at very high speeds. And for you to be really successful adopting telemetry, you have to know all the details about the implementation. I have today around 30 minutes. I might be slightly over the time because I have a lot of slides and I have a lot of questions there. And the goal of my session today is to give you some questions that you should ask yourself and ask your vendors about telemetry, because saying just I can stream a lot of counters every, say, 5 seconds or every 1 second is not good enough for you to start your journey into telemetry. And I will not spend a lot of time just talking about what telemetry is. I assume that you know or at least heard about telemetry. But just a quick recap. For many years, there has been a lot of attention given to the programmability side of networking equipment. A lot of documents, posts were written about how you can basically configure a device. But not so much attention was given to the questions of how I can collect information about my device. And telemetry basically was created around maybe 3 years ago and from networking side. And telemetry is not really something new, because despite of the role of your box, it can be backbone router or data center router, it already has all the internal states, all the internal databases ready for you just to get this information. And the goal or the mission of telemetry is to take as much as possible of useful information and very fast deliver it in reliable fashion to some collection, some analytics tool. And we are talking about seconds or maybe fractions of the seconds. And it should be really deterministic over the time, right? You want to expect that you have this 1 second cadence today, and 1 month later, you will still see this 1 second. And at the end, it should be really easy for you, right? When I was thinking about this session, I decided to split my deck into 3 biggest parts. So I will touch the questions that deal with router itself, the link between the router and the collector. And then just some final thoughts that I want to share with you. I've been thinking for some time, what is the best way to describe telemetry within a router? And I was not able to find a better way than just to show telemetry in layers. And this is kind of similar to OSI model, right? Something that every networking engineer knows from, from the very beginning. And the very bottom layer is something that you probably don't care a lot in your day-to-day activities, but it contains all those databases within a router, all those different counters, internal counters that basically you want to get out of the box. And this is exactly solved on the layer above, right? The layer where you define that, okay, I want these counters, that counters, and so on. As soon as you defined the counters that you want, you need to understand how fast you want each piece of data to be streamed out. And this is exactly the layer above. And the final layer, when you defined your data, when you realized how fast you want everything out, you need to understand how you want to encode this information and how you want to deliver in the most optimal way. And the general message here is that as soon as you approach to your vendor with telemetry questions, you should believe that every layer should be independent. It's similar like in OSI model, right? Because for instance, if today you're using model number 2, encoding number 3, and transmit number 1, tomorrow you might want to switch to models number 1, encoding number 3, and transmit number 3. And for you, it should be really easy. Just do a new config and click commit, and that's it. And there are obviously benefits from the vendor side, because if the vendor itself has a proper stack of telemetry inside the router, if the day after tomorrow a new encoding comes, it will be very easy for the vendor just to add this encoding and not to rebuild the whole infrastructure, and that can take months or a year. When it comes to models, today we have almost 2 general approaches. The first approach is to have native models or proprietary models, those models that are defined by any vendor, and every vendor has its own models. And another approach is open models, models that are supposed to be independent from the vendor and that should be very convenient for consumers of this information. And today, OpenConfig is this way, open way to go. When you go to OpenConfig models, and you probably want to go with OpenConfig models, you should basically ask, again, your vendor about how OpenConfig is mapped within the router. Because there can be 2 ways how any model can be mapped to OpenConfig model. It can be mapped natively to the databases, or it can be mapped through proprietary databases, through proprietary models, sorry. And obviously, OpenConfig model can have differences from the native model. And those differences or deviations, they are posted usually somewhere like on GitHub. And sometimes they just might not work for telemetry. They might work for configuration mode, but not for telemetry. So if you end up knowing that you need some counter from that deviation, you basically should ask your vendor whether they support this deviation in telemetry, and at the end, can OpenConfig model be mapped natively to the databases? The next question comes with that sample interval, right? We can hear most of the time, you can stream information every 5 seconds, you can stream information every 1 second or 30 seconds. But what it does really mean? And there are 2 ways how you can have sampling or cadence work. The first way is that your sample interval starts counting after collection is done and sent out. And the second way, you can have sample interval works in strict intervals, right? At the same time every moment. And there are pros and cons in every way. Like in the first situation, you will never probably see missed collection. And the missed collection is a situation when your sample interval is already over and you need to stream information out, but you don't have this information out. And internally, this will be considered as missed collection. But you might see this on the second way, on the second mode, when you have strict collections. On the other hand, with strict collections or strict mode, you can try to do some automation, because in the first case, collection time might be different and sending might be different due to a number of reasons. And if you want to automate and you want to know exactly when you will have some information out, strict timers is the best way to go for you. Again, if you want to know this, you should ask your vendor or vendors how it is done. And talking about missed collections, there is a question like, okay, I have no data to be streamed out, but what should my router do in that moment? And it can basically send all zeros, right? Or ones, all ones. Or might be it can send previous numbers, previous values, if it is stored somewhere inside. Or most probably, the router will not do anything and will just silently ignore this. And you will be able to work on your receiving side using your receiving logic to fill that gap in the collection side. Again, for you, when you meet this situation, it is better for you to know in advance how your box will behave and what you can do in those cases. And here is the same snapshot as from the first slide, but right now I put the most popular encoding and transport protocols that exist today across different vendors and different kind of models here as well. And many times when I talk with customers about what is the best way to proceed with these, most of the customers think that going with gRPC, GPB, and OpenConfig should be the best way to go, because it is kind of should be independent, right? Because gRPC is the protocol that claimed to be supported by most of the vendors. The same with Google protobuf that is used as encoding, and OpenConfig models, as we talked already, they're supposed to be independent from the vendor. And this is kind of true, but again, there are still details that you should know. gRPC is a transport, right? It's remote procedure call. And if to think about this, it is just an algorithm that is inside your router and in your collector site or your server, and basically defines the actions that should happen when specific message is received. So it's just a list of rules. And you should define this list of rules. And this is done using proto files. This is done for gRPC, right? And GPB is the encoding, Google protobuf. It defines how to most optimally encode all the string information from your databases to be very efficient on the wire. And again, you need some protofile to define that information. And on this slide, I put a snapshot from protofile definitions from Cisco side, and here is an example of protofiles from Juniper side. And as you can see, two companies did them differently, right? They followed different ways, and it is not that horrible, but for you to have gRPC plus GPB support on your collection side, you should basically have all protofiles available with you, and you should integrate them on your collection side to have this working. And this might sound not so optimal for you, and that's why GNMI was created. GNMI is a new way that defines both encoding and transport in the single protofile. So it is posted on GitHub, led by Google mostly. And it defines everything, and so far so good. But there are several messages defined in GNMI that can do configuration, and in our case, telemetry. And one of the important messages is update. And with an update, you can have different typed values. You can stream information from your router using just specific value, like string or integer or signed integer and so on. But there is a specific field that is called Google protobuf any. And basically, this is a way for you to define some previous proto file to be used with JNMI. So, and basically it means that if any vendor wants to just reuse already created proto files, they can just make a reference to the previous file and that's it. So if you want to go with JNMI to have the same behavior across different vendors, again, you should ask them about what is the way of JNMI they have, how they define those values for you to properly configure your receiving side. Those were just several questions from the router side, not so obvious questions. There are many more, but well, let's switch to the link between the router and the collector side. As of today, there are 3 major protocols of ways how you can deliver information from your router to collector. The first protocol is gRPC or Google RPC, and this is kind of the most popular choice so far. It can deliver a lot of information, and it is pretty efficient and has a number of cool things inside, and we will talk about these. Second option available today is TCP. TCP is a well-known protocol. It can work over slow links. It can work over fast links. It can deliver information efficiently. It is connection-oriented protocol. And the final option is UDP. UDP can also deliver things fast because there is no need for any negotiation with UDP, but there is no guarantee that your information will be delivered. gRPC is based on HTTP2 and based on TCP, and HTTP2 brings a lot of negotiation at the very beginning of the connection. And during that negotiation, the router and the collector, they just try to exchange different types of information about like which kind of encoding to use. And this brings one good benefit that I consider the best benefit for gRPC is that it can bring you TCP-like capability of windowing mechanism, but from the application layer. So when you have your server and it is overloaded, for instance, it can send window update messages back to the router for the router to slow down, and vice versa. It can send information, okay, just please expand your window, just start sending me more data. And this is done from the application layer, and this is the only protocol that can deliver this information. TCP and UDP are really simple. With TCP, you have just the usual 3-way handshake, and then information is just pushed away. With UDP, as soon as you configure it and everything internally is resolved, information will be pushed out instantly. But as I mentioned, there are several possible encodings that you can have with your telemetry. And you should know that with TCP and UDP, there is no negotiation happening between the router and the collector. And it means that you need to pass information about encoding used somehow. And you might expect that with TCP and UDP, you will have some additional header inside the data. And I already met a couple of situations when people tried to create their own collector or receiving side using TCP and UDP, and they were not able just because they didn't pay attention that there is some additional header within TCP and UDP just to deliver information about encoding and so on. There is one more point regarding UDP. UDP is not only non-reliable protocol from delivery point of view, but for instance, with TCP works with stream of data, right? It has window mechanism, sliding window. You have acknowledged bits, non-acknowledged bits, and so on. And but UDP works with datagrams, and it has a limit size. And for instance, if you have a young model that defines some internal counters, and that young model is not defined properly, so without proper hierarchy inside, you might end up with a situation when you will have a lot of counters to be pushed out, but they will not be just able to be inserted into UDP datagram. Yes, you obviously have fragmentation on the IP layer, but before you get to the IP layer, you need to put your information into layer 4. And you will end up having internal errors within the box. So just be aware that there are several concerns about UDP as the transport. Another moment that you should ask yourself is whether you need or not encryption. gRPC is the only protocol that supports encryption via TLS. I had a number of situations when a customer just started using TCP or UDP without any encryption, and then local security team just came and said, like, guys, why I can see information using Wireshark? And they had to switch to gRPC. And without encryption, for instance, if you have gRPC dial-in, you will be able to get information about your username and password that you use to access the box. And in both cases, in gRPC dial-in and dial-out, you will be able to see the content of the message that you're transferring. You should also understand which encoding to use, right? There are obvious benefits using GPB or compact GPB, Google Protobuf. It is almost four times less than the same message using key-value GPB or JSON. And here is a snapshot from each encoding protocol with information regarding just one interface. Just interface counters from a single interface from the same router. And as you can see, GPB takes like 4 times less. Key-value GPB and JSON, they have more strings inside. That's why they take more information. GPB saves a lot of bandwidth, but to decode the information from GPB, you need to have proto files. So if you have several young models, you will need to have several proto files for every young model. And you should also be ready to have your infrastructure properly configured for telemetry. Here is a summary information about peak bandwidth consumption for just a single router sending 315,000 counters. As you can see, information using GPB takes less than 10 megabits. And it might go up to 40 gigabits in case of JSON. And this is peak bandwidth, right? Because when you have telemetry, you will see something like waveform of data to be pushed out, right? When the information is ready to be streamed out, it will be streamed, and usually it will be the peak. So if you, for instance, reduce your sample interval, you will just see those peaks coming sooner. And you need to adapt your bandwidth exactly for those peaks. And the final thing that I want to cover today is collector side. So we took the data out of the router, we delivered this to the collector, and now there is time to get information collected. If you ask me what is the most common problem seen across different installations, I would say that this is the collection side of the telemetry. I've seen a number of tag cases opened, like telemetry doesn't work really fast. Something is wrong with your router, just fix it. And when you start debugging it, you will see that in most of the cases, there is some issue going on with the collection side. Because telemetry streams really a lot of data, and it can do it really fast. And here is an example that I used in my collector. Just at the very beginning, I had situation normally. I just had several routers streaming information at some cadence. And then I started to increase the number of counters and decrease sample interval. And at some point, you see that the collector asked to stop sending messages. And a few seconds ahead of this, I checked what is the buffer utilization of the router. And you can see that the buffer was growing. And after collector was able to process all the information, it sent window update again, just router, can you please send me more information? And then you see it started growing and then falling again. So just the main message here is that when you see that telemetry stopped working, just try to check your collection side. Make sure that your server is good enough to process all the information that you're trying to stream there. Another point that is probably clear for guys that work a lot with servers, but sometimes it is not so clear for networking guys, is that as soon as you go with telemetry in your server, you should go with SSD drives. You should really have very fast write speed on your disks. Otherwise, this window of empty information will be growing. So as soon as you will start adding more counters and more routers to be streamed to your collection side, and if you don't enough speed from your hard drive, you will see that information just not present there. And the same actually is important about your database. This is not my table. I found this table in the internet, but I find this really interesting table. It contains an overview of different databases that can be used for different data, including, for instance, in our case, telemetry. I put here just 4 of them, the most popular across different installations. And from my side, I have several points that are under biggest interest. The first one is compression ratio. You will stream really a lot of data, and most of the data at the end, after decoding, it will be based in strings. And what you want is to have some good compression mechanism inside your database, just not to store all the data as is. Otherwise, you will be out of space very soon. Another 2 important moments about your database is your write and read performance. You will stream information, you know, every 1 second, every 5 seconds. And you want to be sure that database is good enough to write this information, and then you will need to extract this information, and query speed should also be really fast. And if you're doing your first steps with open source tools, you want to be sure that when you have a question, and you will obviously have a question, or several of them, you will have an answer for this, right? So you might wonder about the community size, about how many people can really help you with this. The final thing about collection side here is that I've seen a number of cases that like everything is working fine. I can see my router that streams information out. I see my database that, yes, I have some data there, but I don't see anything in my visualization tool. What's going on? And in many cases, people just forget to update the clock time on the router and on the collector side. You have timestamps on every sample, telemetry sample. And what you want is to have this time to be synced up between the collector and the router. Otherwise, you will have the data, but in the wrong time. My final thoughts here, just try to think about telemetry as your overall solution. It's not like having just one router and sending information to just one collector. Here is just an example. You have a router and you have 2 different collectors. You're streaming information, everything is fine so far. At some point, collector number 2 starts just delaying information. It has not enough power just to process the data. Just something has happened. Obviously, at some point, this collector number 2 will send a window update to the router using gRPC. Like, can you please slow down? I need more time to process the data. The router will start keeping information in the send buffer, just to give more time for the collector to process the information. And yes, at some point, collector number 2 will send window update like, yes, everything is good, please speed up, send me all the data. And here will be the question, right? Queues in routers work in FIFA mode, right? First in, first out. You should, basically the logic of the router will be to send information from here, right? From the top of the line of the queue. But it will contain old data, right? While information at the bottom will be recent data, and you want to have the recent data for yourself. On the other hand, if you have several destinations, do you have a proper design in this router that delays in collector number 2 will not affect collector number 1? So you want to be sure that information, that if something is delayed on this direction, it will not be delayed on the collector number 1. And if it is really so, how it is done internally? Do you need to go twice through the counters to send them separately to every destination or not? And the final question here maybe I should not even send information to the buffer, right? And if something goes wrong here on the collector number 2, maybe I should just have this information available inside the databases and just start sending the latest counters as soon as I am ready, when collector 2 is ready. So there are really many questions that you should ask and you should understand before switching to telemetry. And April 16, 2010, trip in Shanghai. Sebastian Boyemi, a young driver from Toro Rosso team, he tried to slow down from 320 kilometers per hour to 60 kilometers per hour, just to make a right turn. But his front wheels were not good enough to withhold the G-force from this slow down motion, and they just broke up. And the reason was that engineering team from his company, they just didn't do a proper job of testing these new wheels with his car. And thankfully, this guy was alive, and it was just one of the funny episodes from Formula One. And telemetry might be not as equal as driving 300 kilometers per hour, but it's still good to know how it works internally, because we are talking about seconds of speed, right? It is really fast, and for you to have success with telemetry, you really need to understand how it works internally before you jump into this field. Thank you.